For decades, scientists agreed nothing should exist beyond the Dark Ages. No stars, no galaxies, no light. It was supposed to be an empty, silent void, the universe holding its breath before life could begin. So when James Webb pointed its mirrors into that forbidden zone and found something shining back, nobody had an explanation. And honestly, they still don't. To understand why this is so shocking, we need to go back to the very beginning. About 13.8 billion years ago, the Big Bang unleashed an unimaginable explosion of energy and matter. In those first few 100,000 years, the universe was a seething, opaque plasma, a fog so dense that even light couldn't travel through it. Then, around 380,000 years after the Big Bang, the universe cooled enough for protons and electrons to combine and form neutral hydrogen atoms. Light was suddenly free to travel. That moment is what we detect today as the cosmic microwave background, the oldest light in the universe. But here's the catch. After that brief flash of freedom, the universe went dark again. For hundreds of millions of years, there were no stars, no galaxies, but vast, cold clouds of neutral hydrogen drifting through the void. Astronomers call this the cosmic dark ages. And for decades, our best cosmological models told us that galaxies, true organized structures with billions of stars, couldn't possibly have formed during this period. The physics simply didn't allow for it. Our models predicted that the very first galaxies would only start flickering to life around 400 to 500 million years after the Big Bang, small and faint and primitive, barely holding together under their own gravity. James Webb just proved those models wrong, badly wrong. In May 2024, a team of astronomers announced the discovery of JADES GSZ 140, and the astronomy world quietly had a breakdown. Using Webb's near-infrared spectrograph, the team confirmed that this galaxy existed just 290 million years after the Big Bang. That alone was a record. But what they found when they looked closer is what turned heads around the world. This galaxy was not small and faint and primitive, the way our models said it should be. It was enormous. It contained several hundreds of millions of times the mass of our own sun. It was pouring out light, 5 times more luminous than the previous record holder. As University of Arizona professor Kevin Hainline put it, nobody dreamed that there would be galaxies this bright at this high a redshift. But the real stunner came from Webb's mid-infrared instrument, MIRI. Researcher Jake Helton detected something in this galaxy that no one expected: oxygen. Think about what that means for a moment. Oxygen is not a primordial element. The early universe contained only hydrogen, helium, and tiny traces of lithium. Oxygen has to be forged inside the cores of massive stars, then blasted into space when those stars explode as supernovae. For oxygen to exist in a galaxy 290 million years after the Big Bang, that galaxy must have already cycled through at least one generation of massive stars. Stars that were born, burned furiously, and died, all within the first blink of cosmic time. Scientists at NASA stated that all of these observations together tell us that JADES GSZ 140 is not like the types of galaxies that have been predicted by theoretical models and computer simulations to exist in the very early universe. They found no suitable analogs among the hundreds of other galaxies they had observed. Just when astronomers were still processing JADES GSZ 140, Webb did it again. In May 2025, a team led by researchers at MIT confirmed the existence of MOM-Z14, a galaxy with a redshift of 14.44, making it the most distant, spectroscopically confirmed galaxy ever observed. It existed just 280 million years after the Big Bang, pushing the record back another 10 million years. MOM-Z14 is curious in its own right. It's only about 240 light-years across, 400 times smaller than the Milky Way. Yet the amount of light it emits is wildly disproportionate to its size. It also contains unusually high levels of nitrogen relative to carbon, a chemical fingerprint eerily similar to the globular clusters that orbit our own galaxy today, clusters that are considered among the oldest structures in the known universe. The researchers noted that this unexpected population of luminous ancient galaxies has electrified the community and raised fundamental questions about galaxy formation in the first 500 million years after the Big Bang. But 2 galaxies can be a coincidence, 300 cannot. In August 2025, astronomers at the University of Missouri published a study that has the scientific community buzzing. Using deep-field images from Webb, they identified 300 unusually bright cosmic objects in the early universe. Using a technique called the dropout method, which identifies galaxies by finding objects that appear in redder wavelengths but vanish completely in bluer ones, they flagged these candidates as potential galaxies from the very first chapter of cosmic history. Haojing Yan, the astronomy professor who co-authored the study, put it plainly: if even a few of these objects turn out to be what we think they are, their discovery could challenge current ideas about how galaxies formed in the early universe. And here's the key: these objects are brighter than they have any right to be. Our standard models say galaxies forming so soon after the Big Bang should be dim, limited by how fast they could accumulate mass and light up stars. These 300 candidates are blowing past that theoretical ceiling. One has already been spectroscopically confirmed. Spectroscopy, the gold standard of astronomical verification, confirmed it as a genuine early universe galaxy. The team is now working to confirm the rest. If they do, cosmology will need a serious rethink. So what's actually going on? There are several possibilities on the table right now, and scientists are debating all of them. One idea is that our current cosmological model, called Lambda CDM, the standard model of cosmology, built on cold dark matter and dark energy, needs to be modified, not replaced. Some researchers have proposed that gravity may behave slightly differently at cosmic scales than we've accounted for, allowing matter to collapse into stars and galaxies faster than current simulations predict. Another possibility involves dark matter itself. Some models suggest that if dark matter particles had different properties, or if there were more types of dark matter than we know, the gravitational seeds of early galaxies could have grown far more rapidly. This could explain why we're seeing galaxies that look hundreds of millions of years older than they should. There's also the question of star formation efficiency. Webb's findings suggest that early galaxies may have converted gas into stars at a much higher rate than galaxies do today. If that's true, it doesn't break the laws of physics, but it does mean our simulations have been dramatically underestimating how active the early universe was. And then there's the most provocative possibility, that the universe is older or more complex in its early history than our current models allow. Perhaps the timeline of the Big Bang itself, or the physics of the moments right after it, contains chapters we haven't yet written. Here's what makes all of this so profound. The Lambda CDM model has been the bedrock of cosmology for decades. It has successfully predicted the large-scale structure of the universe, the behavior of galaxy clusters, the distribution of dark matter, and the accelerating expansion of space. It is, by any measure, one of the most successful scientific models ever constructed. And Webb is stressing it at every seam. In just over 3 years of science operations, Webb has broken the record for the most distant galaxy multiple times. It has found the most distant black hole, the most distant galaxy protocluster, the most distant red supergiant star, and the most distant gravitational lens. Each of these discoveries has pushed the boundaries of what we thought was possible in the early universe. But perhaps the most important implication isn't about records, it's about chemistry. The detection of oxygen in a galaxy just 290 million years old tells us that the universe got to work fast, faster than we imagined. Stars were forming, living their entire lives and exploding, enriching space with heavy elements, all within a sliver of cosmic time. That means the raw materials for planets, for chemistry, perhaps for life itself, were being produced far earlier in the universe's history than we ever suspected. The confirmations are coming. The 300 candidate galaxies from the University of Missouri study are awaiting spectroscopic follow-up. If even a fraction of them are confirmed, the data will be undeniable. The Nancy Grace Roman Space Telescope, currently targeted for launch in 2026, is designed to scan vast swaths of sky, far wider than Webb's deep field views, and could reveal thousands more of these early, impossibly bright galaxies. The picture may get far stranger before it gets clearer. The researchers behind MOMZ-14 wrote something in their paper that stopped me cold. They said that previously unimaginable redshifts, approaching the era of the very first stars, no longer seem far away. Read that again. The era of the very first stars. Webb may be close to seeing the very first light that ever switched on in the universe. We are living through a revolution in how humanity understands its own origins. Every image Webb sends back is a message from the deep past, a postcard from an era we thought was lost to darkness. And what those postcards are telling us is this: the universe was alive and burning and building far earlier and far more vigorously than we ever dreamed. The Dark Ages weren't as dark as we thought, and the story of the cosmos is going to have to be rewritten. Drop your thoughts in the comments. Do you think Webb is about to completely overturn the standard model of cosmology? Or do you think these discoveries will be absorbed into a refined version of what we already know? And if you haven't subscribed yet, now is a genuinely great time, because this story is only getting bigger.